Thanks for joining me for example 7.8.1. We're told that x and y have joint cumulative distribution function f of xy given here on the support given here, 0 is less than or equal to y is less than or equal to x is less than or equal to 1, and we're expected to find, well, that's true, we are asked to find the expected value of y. And so we are going to use the fact that Lotus tells us that we can integrate from minus infinity to infinity, again, minus infinity to infinity of the function, which is just y, times the density, f of xy dy dx. And so if we can get the density function, then we can use this double integral to find the expected value of y. So we are going to use the property that this density function, f of xy, just happens to be the mixed partial of the joint CDF dx dy. So that is the derivative with respect to x of, and let's take the derivative here then with respect to y. So we're going to have x squared plus 2xy minus 3y squared, and then we now take the derivative with respect to x inside, and so we are going to get 2x plus 2y plus 0, and this is on the same 0 is less than or equal to y is less than or equal to x is less than or equal to 1. So if we want this expected value now, this double integral, we can just do the integral from, well, let's look at the support and write this double integral immediately with the correct bounds. So we have 0 is less than or equal to y, which is less than or equal to x. So we're going to the line y equals x. And from x is 0 to 1, so there's the support. And so we're going to go from 0 to 1, and y will go from 0 to x of y times the density function, and that density function is given right there. So y times 2x plus 2y, and we've got it in the order dy dx. So we've got the integral from 0 to 1, the integral from 0 to x of 2xy plus 2y squared dy dx. So anti-differentiating the first term, so integral from 0 to 1. So what do we have here? xy squared plus 2/3 y cubed, which is going to go from 0 to x dx. And then we're almost through. We have the integral from 0 to 1. We're going to have x cubed plus 2/3 x cubed minus 0 dx. So if we combine those, we get the integral from 0 to 1 of 3/3 5/3 x cubed dx, which, so 1/4 x to the 4th, and so we're getting 5/12 x to the 4th from 0 to 1, or 5/12 minus 0 is equal to 5/12. So actually the bulk of this example was using Lotus and the integration of a double integral, right? We used one property of the joint cumulative distribution function, and that is the mixed partial of that function gives us the joint density function of both variables.